Yo, what's up, swaggers? This is Math for Swaggers, and today we're going to be diving deeper into exponent laws. I'm your teacher, raddest. Let's see if I can teach you some maths. Okay, guys, so as you can see, there are 6 exponential rules, and we're going to be going from the first all the way to the bottom, and hopefully at the end of the video, you'll be able to understand what each of these mean, as well as how to work them out. Okay, swaggers, so the first rule is called the multiplication rule, and it's x to the power of a number times x to the power of another number is equal to x to the power of the first number plus the second number. Okay, so for the first example, we got a basic one, which is 5 to the power of 2, or 5 squared, times 5 to the power of 5 is equal to 5 to the power of 2 plus 5, which is just 5 to the power of 7. Okay, so same thing's going on later, it's just r for raddest. Of course, I need it to be an homage here. Is that how you say it? I don't think that's how you say it, man. Okay, I searched it up and Google Translate's telling me it's homage, like pay an homage to. So don't cancel me. Okay, guys, so anyway, same thing with the r. It's just r to the power of 4 times r to the power of 6 is equal to r to the power of 4 plus 6, so it's just r to the power of 10. Now onto the hard one. Okay, after multiple times, I have reached the conclusion that I am incapable of reading what that says, so I'm just gonna work through it instead. Okay, so first we're gonna multiply the x terms, and so we're gonna do 2x cubed times 4x squared, and the answer to that's gonna be 8x to the power of 5. And you might be thinking, well, x cubed times x squared isn't x to the power of 5. It is, though, because of the multiplication rule, right? So it's just gonna be x cubed. Well, I'm just going to say the numbers on top. I think it's going to be easier to visualize. It's just 3 plus 2 equal to 5. So then the 5 is going to be the exponent of the x. You get it? Look at the rule on top if you can't visualize that clearly. Okay, so now we just move on to the second part, and that's multiplying the y values. So now we just do 2 plus 5 is equal to 7, so then it's going to be y to the power of 7. And then we just do first value times second value, and that's the end of the song. It's not a song though. Oh my god, you got fooled. No way. Don't unfollow me, please. Actually, I think you should actually follow me instead, because I said sorry. Like, what? Who says sorry these days? This is actually a really big problem though. If you're watching this and you don't say sorry, you should start saying sorry. Not to like, oh, I'm sorry for existing. Oh, like, don't do that. But be like, if you do something bad, just say sorry. Acknowledge it, you know? Life lessons by raddest. Yo! Okay, so the division rule is very similar to the multiplication rule. It's just subtracting instead of adding. For this very special reason, I'm not going to go through the first 2 ones because I think you can catch on that. So on to the hard one it is. You can see it's a fraction, but as we know, fractions are the same as dividing. So same rules before, guys. Start with the x factors, or in this case, a factors, and then do the b factors in this case later. So then we got 12a to the power of 7 divided by 3a cubed is equal to 4a to the power of 4. On to the b values then. B to the power of 4 divided by b squared is just b squared, because 4 minus 2 is 2, right? Okay, so now it's the power of a power rule, guys. So in my words, first exponent brackets second exponent is the same as first exponent times the second one. So as you can see here on the first example, it's just 4 times 2 is equal to 8, so then it'd be 3 to the power of 8. So in the second example, it's basically the same thing. It's just a 3 times 7, so r to the power of 21. Okay, on to the hard one. We start by solving the internal values first. So we start by doing this value here first, and then the second one, and then the third one. So the 2 becomes 2 squared, which we now know is 4. The second value would be x to the power of 2 times 3, which is just x to the power of 6. And the third value would simply be y squared. Okay, so that's it for the first brackets. Now on to the second one. So first we need to do 4 cubed, which is equal to 64. And then x to the power of 6 times 3, which is just x to the power of 18. And then last but not least, we have y to the power of 2 times 3, which is just y to the power of 6. Okay, guys, now the zero power rule is probably the easiest of all of these. It just says that anything when raised to the power of 0 is equal to 1. You can see that in the first two examples, and on a third one, you just have to make sure you don't mistake the whole thing for 1, since it's only the numerator that's being raised to the power of 0. The 4 on the denominator isn't. Okie schmokie, now on to the negative exponent rule. Now that rule states that the base raised to a positive power is equal to the reciprocal of that base raised to the positive power. And you might be wondering what a reciprocal is. And it's basically just flipping the denominator and the numerator around. Now take a look at the first example. We can see that there's a 3 being raised to the power of negative 2. And you might think that 3 is all on its own. But always remember that no matter how lonely you are, there is always a positive 1 holding you up. Since we learned that everyone has a positive 1 holding each other up, the same goes for the 3 and all of the numbers. That was supposed to be a really cool analogy. Let me know if your thoughts are in the comments. Let's follow the steps of the rule for the first example, okay? So 3 over 1. We make it a reciprocal, so now it's 1 over 3. And now the sign of the exponent will be flipped around, and so it's going to be positive now. Same goes for the second example. We flip the denominator and numerator, and we switch the sign of the exponent. So now on to the hard one. 2x to the power of minus 3 times y squared over 4x squared times y to the power of minus 1. You read it in one go! Anyway, so first thing we do is we simplify the 2 and the 4 by dividing it by 2. Here we can use the division rule. So first with the x. X to the power of minus 3 over x squared is equal to x to the power of minus 3 minus 2, which is just x to the power of minus 5. And we also have y squared over y to the power of minus 1. And that's y to the power of 2 minus 1, which is just y to the power of 2 plus 1, which is y cubed. Here's where we use the negative exponent rule. You can see that the 1/2 is being multiplied by x to the power of minus 5. And if we flip and switch the x to the power of minus 5, we get 1 over x to the power of 5. So now we're actually left with this. And 1 times y to the power of 3 is just y cubed. The denominator, 2 times x to the power of 5 times 1 is just with the result of y cubed over 2x to the power of 5. Okay guys, last rule, the fractional exponent rule. Now take a look at the formula. Imagine a sun top of x to the power of m over n. Now you see that m is in the sun here, right? With this rule, when you turn it into a radical, m would be under the radical, so taking cover from the sun. N that was taking cover before is now exposed. That's how my teachers taught it, and that's how I'll always remember it. Okay, so on to the first example. We have 25 to the power of 1/2. Take the denominator, 2, and place it on top of the root. But since this would be the square root, you don't have to put the 2. Same goes for the 1, as everything's being raised to the power of 1. Well, square root of 25 is just 5. The second example, we have 8 to the power of 2/3. Let's save the 2 from getting a sunburn, and let's put it under the shadow beneath the radical sign. Now let's let 3 tan a little bit, which leaves us with the cube root of 8 squared. 8 squared is 64, and the cube root of 64 is just 4. You will notice that I didn't write a hard example for this question, and that is because many reasons really, but it's the end of the video. I'm tired, you're tired, and I do think that after this rad math video, you know enough about exponent rules already. So bye, you guys. See you in the next video. This is Math for Swaggers, and I'll stop with the chatters and clap your hands and up your stand, cause the rad math teacher has a subscribing feature. Yeah.